Welcome to the video for introducing particles, which in your textbook is C1.1.1. So before we start, we need to think about what previous knowledge from Key Stage 3 we need to know. So from Year 7 and Year 8, you should have learned that all matter is made from particles and that there's three states of matter: solid, liquid and gas. And you should have also learned that those different states of matter have got different arrangement of particles. Now, some of you might be able to remember what those arrangements are, but if you don't worry, because we're going to go over it in this lesson. So our learning objectives are to draw diagrams to show the arrangement of particles in solids, liquids and gases, to be able to describe the forces acting between the particles in solids, liquids and gases and describe the motion of those particles. And lastly, some of you should be able to use the particle model that we've drawn and described to explain the properties of solids, liquids and gases and how they're different, because that's linked to their particle model. So before we start, I want you to pause the video in a minute, because I want you to think about how the particles are arranged in solids, liquids and gases. And if you can, I want you to pause the video and try and draw a particle diagram of solids, liquids and gases now. And then once you're done, go on to the next slide. So hopefully you've drawn something like this. So in a solid, you've got nice, neat, ordered rows of your particles. In a liquid, you've got a more random arrangement. I like to use the word higgledy-piggledy, but it's not used very often, so random would be better to write in an exam. And then in a liquid, they're still, even though they're random, they're still quite close to each other. So there's slight gaps in between them, but not much. So the gaps between them shouldn't really be any bigger than the particle itself. And then in the gas, you've got a lot fewer particles in the same volume, and they're very far apart, and they're not touching. So they're not touching each other. Quite often when people draw these diagrams, they draw the liquid a bit more like the gas. So you have to be careful that when you draw the liquid, that even though they're random, they're still pretty much touching each other. So every particle should be touching another one, at least one. So we're going to take these one at a time and look at the properties of these particle diagrams, and then look at how that explains the physical properties that we know how solids behave. So you need to copy this slide into your notes. So if you've not drawn it already, you need to draw a solid particle diagram showing them in nice, neat ordered rows, making sure they're all touching each other. So if you were asked to describe rather than draw the arrangement of particles in a solid, you would describe it as neat ordered rows. In terms of space between the particles, there's no space between the particles. So if you look at this diagram, you can see the background is shaded, but that's just the colour of the container. It's not showing that there's anything in between the particles, because there is nothing in between the particles. In terms of movement, if you're asked to describe the movement, quite often people describe that there's no movement in a solid in the particles, and that's not true. They don't move past each other, but they do vibrate about a fixed position, and I'm going to show you this on a simulation in a minute. And then the forces of attraction between the particles. So the forces of attraction between the particles are very strong, and that's why they don't move past each other and why they're close together, because the forces of attraction between the particles are strong. In terms of physical properties of solids, we know that they can't easily be compressed, and that's because there's no spaces between the particles, and the particles themselves you can't squash. So if there's no space between them, then the solid can't be compressed itself. So in terms of solids flowing, we know that unless you've got lots of small particles like sand, then that flows, but that's just to do with the particle size. And by that, I don't mean the atoms or molecules or ions like we're drawing diagrams here. I mean the lumps of the sand, so the lumps of the solid. So most solids will not flow, and that's because there's strong forces of attraction between the particles. That means that they can't move past each other. So a solid will have a fixed volume, and that's because there's no spaces between the particles, so the volume can't get smaller. And because there's strong forces of attraction between them, the volume can't get bigger, because the particles can't move away from each other. And that's the same for the fixed shape. So a solid will have a fixed shape because there's strong force of attraction between the particles, which means that they can't move relative to each other. So now moving on to a liquid. So again, you need to copy this down. So in a liquid, we can see If we asked to describe that arrangement, we'd describe it as a random arrangement of particles because they're no longer in nice, neat ordered rows. In terms of space between particles, there's very little, so you've got some slight gaps there, but there shouldn't be any gaps that are big enough to draw a new particle in. In terms of movement, so they don't vibrate anymore, they've got more energy, so they've got more kinetic energy, they can move more, so they flow past each other now, so they can just move past each other. In terms of forces of attraction between the particles, so it's not as strong as in a solid, and that makes sense with the movement, because if the forces of attraction between the particles were as strong as in the solid, then they wouldn't be able to move past each other. But because those forces of attraction have been weakened slightly, then the particles can now move past each other. So can it easily be compressed? The answer, like with solid, is no, because there's very little space between the particles, so they can't be squashed. And again, the particles themselves can't be squashed, so it can only be compressed if you can put those particles in a smaller volume. And because there's very little space between the particles, there's no space for it to be compressed into. Liquids, unlike solids, do flow, and that's because the particles can move past each other. So you can pour most liquids. Sometimes they're very viscous and they don't flow very well. So if you think about treacle, for example, that's quite viscous, it doesn't flow very well, but it still flows. In terms of volume, it has a fixed volume again. Like the compressed, whether it can be compressed or not, it's got a fixed volume because there's very little space between the particles. Now, in terms of fixed shape, a liquid doesn't have a fixed shape. If I put some water in a cup, it will fill the shape of that container. It will take the shape of that container. If I then pour that water onto the table, so there's no sides to the container, it will spread out. So liquids do not have a fixed shape, and that's because the particles can move past each other, which enables them to take the shape of its container. So onto a gas now. So again, you need to copy this slide. So when we're drawing gas particles, we should draw maybe 2 or 3 very far apart, make sure they're not touching. In an exam, if you draw gas particles that are touching, you will lose marks. So the arrangement, again, like liquid, we describe as random. The space between particles, there's a lot of space between the particles, and their movement is very fast and in all directions. And that's allowed because the forces of attraction between the particles are very weak, which means the particles can move very fast and they can move away from each other and they can move in any direction. Now, gases, sorry about the alert. So gases can be easily compressed, and that's because there's lots of space between the particles. Gases do flow because the particles can move past each other, but they don't have a fixed volume because there's lots of space between the particles. So you can apply pressure and squash those particles so they're close together. Again, they don't have a fixed shape like liquids because the particles can move past each other, so they will take the shape of its container. Right, so there's a task on this slide that I want you to do, so just pause the video and copy that table out and fill it in. If you feel like it, there's an extension task so you can use the arrangement of particles to explain those properties. Use the work we've done on the previous slides to help with this. Okay, so there's the answers. Just check your answers and make sure you've got them correct. The last task, I want you to think about whether custard is a solid or liquid, and then explain your answer. So think about the properties of solids and liquids that we described and use that to explain your answer. I'd also suggest at this point that you watch John Tickle Walking on Custard, which is a Brainiac video. You can type that very long link into Google, into your search engine, or just search on YouTube for John Tickle Walking on Custard. Okay, last thing you need to do is answer the questions. Thank you for listening. See you next time.